This is the video lesson for PreAlgD Solids, section 9.1. Here we're going to identify solids, parts of solids, and skew line segments. Actually, I don't think we're going to do the skew line segment part, so ignore that. Okay, so solids are objects that do not lie flat in a plane. So they're going to be like three-dimensional instead of two-dimensional. So they don't lie flat. They have a length, a width, and a height. So that's the 3 dimensions. Below are some common solids. So here's a prism. So a prism is going to be a solid with 2 parallel bases. So you can see here this pentagon. This is a pentagon 5 shaded figure here on the bottom. And then this one on top. Those are your parallel bases. And then they are congruent polygons. So the top shape is going to be the same as the bottom shape. And they're parallel, so they never touch. And then they're connected by what are called lateral faces, and they're all going to be parallelograms. So you kind of, to draw these, right, you just draw a pentagon, five-sided figure, and then draw the same one, exactly the same, congruent, above it, and then just connect the vertices. And so the top is a base, the bottom is a base, and then these sides are called lateral faces. And then where the lateral faces meet is called a lateral edge, and then where the base meets the lateral face is called a base edge. Okay, so prism is when you have 2 shapes that are the same on the base and the top and the bottom. A pyramid is when you have a base and then the lateral faces go up to one point, which is called the vertex. So you have a base and then they come to a point. So you take each vertex of the base and they meet at a point somewhere above. And then prism is going to be named for the shape of its bases. So here, since the base is a pentagon, this is called a pentagonal prism. A pyramid is also named for the shape of its base. In this case, this is a square. So this would be called a square prism. Sorry, pyramid, not prism, pyramid. And then a cylinder is going to be basically a circular prism. So the bases are circles. And then, so this is just one lateral surface, and then the 2 bases, which are circles. And then a cone is a circular pyramid, where the base is a circle. And it comes, and then they kind of meet up to a point, which is the vertex. So that's a cone. Okay. So with that in mind, let's move to the first example. Refer to the figure at the right. Describe the base, name the figure, and name RL. So in this case here, describe the base. This is the base here. What shape is that? That is a circle. The base is a circle. And then it comes to a point. So it's going to be a pyramid, but in this case, since it's a circle, a circular pyramid is just going to be a cone. So this is a cone. And then RL is the diameter of the base. And then what do they want us to do with that? Diameter of the base? Yeah, that's just the diameter of the base. Okay, so that's not really that helpful because I didn't say that here. So for this one, you're going to do this one on your own, your red star. When it says you're going to need to name, so it says you're going to do the same thing here. You're going to name the figure, name JK, and then name each point J and K. Okay, so try this on your own. Just think about it for a minute. What shape are the bases? Is this a pyramid? Is this a prism? Is this a cylinder or a cone? Decide which one. And then once you see which one that is, actually you can use this, right? Is it is JK a lateral edge, a lateral face, a base edge, a vertex, a base? And then this point J, a base, a vertex, a lateral edge, lateral face. So think about that for a second. Right, and let's go over it. So here we have a 1, 2, 3, 4, 5-sided top and a 1, 2, 3, 4, 5-sided bottom. So congruent pentagons. Pentagon. And then it's a prism. And so we can call it a pentagonal prism. And then JK, right, is where 2 lateral faces meet. That's a lateral edge. JK is a lateral edge. And then it wants to know point J. Point J is just a vertex. Look at that, like vertex is a vertex. And so is point K. Okay. Moving on. Example 2 shows a set design. A stage crew for the school play constructed the ramp shown. Name the 3 solids used to construct the ramp. Well, let's look at this solid here. This one. And we can see that this shape here is a triangle. This shape here is also a triangle, and they are parallel. So this is a triangle, and they're connected. Their vertices are connected. So this is a triangular prism. This shape here has a base that's a rectangle. This has a base that's a rectangle. They're parallel, and their vertices are connected. So this is also a prism, and the base is a rectangle. So it's rectangular. I totally blew that. Rectangular prism. Okay, and then this one here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the 2 bases. They are pentagons, and they are congruent and parallel, and their vertices are connected. And so this is also a prism, and it's a pentagonal prism. So those are the 3 solids. The red star asks you to name 2 solids that make up section C. So think about this just for a minute. Can you cut that pentagonal prism into 2 solids? And what are the 2 solids that it creates? So think about that. And then let's just go over it. Let's imagine cutting it right down here. Like if I was to slice it, not in half, but right on this edge here. Then I'd have this shape here. 1, 2, 3, 4. This looks like a trapezoid. 1, 2, 3, 4. That's a trapezoid too, because these 2 sides are parallel. And then they're parallel and they're connected by vertices. So this one could be, let's write it here because we're answering this. This is a trapezoidal prism. And then this one here, rectangle, congruent rectangle, connected by, the vertices are connected. And so this is a rectangular prism. So the pentagonal prism can be split into this trapezoidal prism and this rectangular prism. Hopefully you can see that. And that's it. We're just learning the names of solids for this. Okay, so here's your homework, page 298, 6 through 9 all. I also made a PDF too, so you could see that in your folder. Enjoy.